All right. Welcome to the jungle, a safari through the JVM landscape. So my name is Gerrit Grunwald. I'm working for AZUL. As a senior developer advocate, I also run the Java user group in Münster in Germany. And this session is about Java and the Java virtual machines, and specifically about the distributions that we have in the area of JVM. So who's a Java developer here? Okay, cool. If you would like to have the slides, you can get them here. And if you don't make a photo right now, you can also ping me on Twitter. So my handle is hansolo_. And these slides might be a little bit different because I change them all the time, but it contains the same information. Okay. OpenJDK. First question for you. Who is running OpenJDK on his computer or her computer? Okay? You're probably wrong, because you don't run OpenJDK. OpenJDK is just the repository, it's the project, it's the source code. You run a build of OpenJDK, and that is a so-called distribution, right? Which is a difference, because when people approach us at the booth and you ask them, what JVM are you running? Oh, OpenJDK. Oh, of course OpenJDK. But so this is a free and open source implementation of the Java Platform Standard Edition, or shortly Java SE. You probably heard that. And it has a website that you can find here, openjdk.org. And because it's an open source project, it also has a repository where you can check out the code, which is here, github.com/openjdk. If you're interested in how it works, you can take a look there, but be aware it's complex. It's not easy, and it's a lot of code. And you can become a committer, which is not easy too. It takes some time to get there. Okay. Because it's an open source project, it also has contributors. And you might think, yeah, that's Oracle, right? Well, it's all these companies are contributing to OpenJDK. And you see there's a point, many individuals, because they're also single persons, they do contributions to the OpenJDK project. So that means, and you see big companies here, like, for example, Amazon or Alibaba, IBM. Who knows Tencent? Wow, that's really impressive, because usually the people don't know that. Or Red Hat or other companies here, right? That means it's not a one-man show, which is a good thing, because if it would only be one company, we would all rely on that one company. But with this, you see lots of companies have an interest in OpenJDK, makes it a safe technology to use even today, also in the future. So it comes, of course, with the roadmap. And this might be some things you already know, but trust me, there will also come some stuff that you probably don't know. So the roadmap, this is the old release cadence, right? So we saw, I just started with JDK 6, and it took 4.5 years to get to JDK 7, and then another 3 years to get to JDK 8. And that means we really had to wait multiple years before we can really test a new JDK. Who remembers these days? Good. And things changed. This is the new release cadence. As you can see, now we have every 6 months, we have a new release. And there are different release types, and I will come to that. But you see, now we only have to wait 6 months before we can test the new JDK, right? Which is a good thing, because the things you have to test are smaller. Because in the past, if you have a JDK release apart from the other one for 4.5 years, that means it's a lot of features in these releases. And it took a long time to really make your new application or your application work on the new JDK. And this is much easier with this shorter release cadence that we have right now. Okay. It seems to be obvious. We have a JDK, we have a JRE, which is the Java Development Kit, and then there is the Java Runtime Engine. Okay. Who's running in production on a JDK here in the audience? Who's running on a JRE? That should be the rest of you. But no, there's one other option, but I will come to that. So the JRE is just the Java virtual machine with the class libraries. This is all you need to run your application. So that's the reason why you should use this one in production, where the JDK contains the JRE, plus it has Java C compiler in the debugger, Javadoc, all these kind of things, okay? So the recommendation is if you go from whatever JDK number up to 8, you should use in development a JDK, of course, in production a JRE. The reason is the JRE is just smaller, right? And if you save space in your cloud environment, that means you save money. Okay, this is for JDKs up to JDK 8, but if you go from JDK 9 onwards, then you should use JLink. Who knows JLink? And who uses JLink in production? See? And that's what I always experience, which is interesting, because JLink is a tool to create a custom Java runtime. That means you build your own JRE, and this is tailored to your application. It only contains the modules that you need. Means it's much smaller than the JRE, right? And also, you decrease the surface for attacks, because if you, for example, never use XML, and maybe there is a vulnerability, why bundle it with a JRE, right? With JLink, you can create a JRE that just contains the stuff that you need. So if you don't use it, at least take a look at it. It's in there since JDK 9. But my experience is from giving this session that most of the people don't use it. And I have no idea why. So the JRE is really a lot bigger than a JLink created custom runtime. So you should take a look at that. It's really worth it. All right, that leads me to distributions, to come back to the things that I asked in the first question. We have builds of OpenJDK, and these are all the distributions out there that I found that make sense. There are even more. And you see that some of them have this little cross on the top. Who's using Adapt OpenJDK still? Why? This project died with 1602. There's no support anymore for this thing. You should really not use it, right? The other one is OJDK build. This is the community build of the Red Hat JDK. And this also is dead now. I think from 17.0, I don't know the version number, maybe 17.03, but they stopped building it. Then we have stuff like Kona. And all the people that raise their hands for Tencent, this is Tencent Kona. And I will come to that later on. Or we have stuff like Tamarin, you probably know that, from Adoptium, from the Eclipse Foundation, or stuff like Bisheng. Who knows Bisheng? This is from Huawei. That means this is a huge distribution in Asia, not in the Western world. And the same goes for ALIBABA DRAGONWELL. This is also something that is in Asia, is quite big, but here, is someone using DRAGONWELL? Probably not. See. So we have all these different distributions. 20, to give you a number. And this is just OpenJDK. Then we have GraalVM. Someone using GraalVM here in production? Okay, one. Native image? Yeah, okay, cool. It's not only one GraalVM version. We have Glue on GraalVM. This is made to create mobile apps with JavaFX using GraalVM for iOS and Android. Then you can have the community build of GraalVM. This is the formerly known GraalVM CE, because they changed that 2 weeks ago. Then there's now called just GraalVM, which was GraalVM Enterprise before. And then there's Liberica Native Image Kit, which is also a build of GraalVM. And there's Mandrel. Liberica is from Bellsoft and Mandrel is from Red Hat. Right? So these are all the different builds that you can find of GraalVM with different features. Okay, that's the question. Which one to choose and why? Right, so who's using, for example, Tamarin here in production? Okay, someone using CORRETTO on AWS? Okay, so there are people that use CORRETTO not on AWS, but locally or on their own environment. Okay, the question is why? Right, so we have to take a look at the differences to understand and to make a decision. And there are different points that I figured out that might make sense to talk about, which the first is term of support, and I will explain all these points. Then there's updates, right? Compliance, cost, performance, features. These are mainly the points where you can make a difference between these JDK distributions. Let's start with term of support. There's STS, short-term support. Probably just a few people heard of that. And there is LTS, and most of you know this one, right? Long-term support versions. And if we have a look at all the distributions, let's say we start from 9, every 6 months we have a new version out there, and then the STS releases are the white ones, short-term support versions, only 6 months. After 6 months, that's it, no support anymore. Why is that important? If we take a look at the LTS releases, you see they have a much longer time of life, right? So, and the 8 is not on here, 8 is even longer. 8 is till 2030, right? You get support for JDK 8. So the difference here, or the important part is, let's say there was a feature in JDK 13 that you would really like to use in production. You can do. You just install JDK 13 on your machine in a production, and you run that using the new feature. 6 months later, JDK 14 will come out. Okay, fine, you don't care. And then there is suddenly a security issue in 14. And Oracle and all the others will fix that in 14, not in 13. There's no support for 13 anymore. That means if you would now have a secure environment, you have to update to 14, 6 months later, right? And then you have to update to 15, and then to 16, and then to 17. And 17, you get updates for a long time. So you have to keep that in mind, because I saw some companies did that with JDK 12. There was, for example, JPackage, which can create native packages from your Java application. And they would love to use that. So, and then we told them, if you stick to 12, you have to wait for a long time, because it was 3 years before you really get a long-term support version. And in between, you always have to switch every 6 months to a new JDK, right? And this is also a little bit risky if you do that in production. So you would like to run it and then just get security updates. That's usually what you would like to do in production. Okay. So that means short-term support releases only for 6 months. After that, it's done. So that means if we talk about 20, then there was 20, 2001, 2002, and then there's 21. There isn't 2003, right? It won't come. So, and then the next thing is, not every distribution gives you a short-term or a short-term support version and a long-term support version. There are distributions, they only have LTS releases. So that means, for example, DRAGONWELL from Alibaba. They have 8, 11, 17, and they will have 21. That means if you, on Alibaba, DRAGONWELL, you only have the chance to update on the long-term support versions. That means it takes years sometimes, right? You have to keep that in mind. Recommendation here, in development, whatever you like. In production, stay on LTS releases. It really makes sense, because you get security updates, right? This is really important. And that leads me to updates, because updates, this is also something that many people don't know. We have different kinds of. There's the CPU or critical patch update. Who knows that? Just 1, 2 maybe. And then there's the patch set update. Who knows this one? Probably nobody. This is the stuff that all of you use, not the CPU, except the 2-person maybe. So what is it? The CPU is a critical patch update, and the name already says that. It only contains fixes for vulnerabilities and critical issues, nothing more. That's it. Where the PSU contains the CPU, but it also has fixes for non-critical issues, and it introduces new features, right? And introducing new features can lead to new issues. Because if you just add something to the JDK, okay, they test it before it will be released, but still there might be an issue that nobody found, and then suddenly this issue happens in your production environment. It's not a good idea, right? That's the reason why we have CPU releases. And we get them 4 times a year. They come together with the PSU releases, and let me give you an idea how it works. So on the top row, we see the PSU, right? Patch set update. It contains the CPU, the light blue box. And on the bottom, we just see the CPU, right? This is only the critical patch update. 1701, January, and then when the next release comes out, in April, the 1702, what happens is that this one introduces fixes and features, plus the security fixes, and the other one only contains fixes for vulnerabilities and critical issues from the 1701. And what does it mean? It means that the 1702 critical patch update doesn't contain the features that are in the 1702 PSU. So feature-wise, you're always one step behind the PSU, right? And this is a good thing, because new features have been introduced and the next CPU only contains the fixes from the last PSU, nothing more. And that goes on. In July, we have the same, and there's a problem with my slides here. And then in October, there's the last one, and the same. You have to keep in mind, CPU are always one step behind feature-wise. The fixes are the same, but the features are different, right? So in the PSU, you get the features. Okay. Where do you get the patch set update? All of the distributions. If you download your stuff from the internet, this is the PSU updates, all of them. And even if you take a look at the Adoptium Tamarind page, they make a very smart move, because they say, oh, this one contains all the critical patch fixes. Yes, of course, but it also contains non-critical issues, right? Fixes for non-critical issues and features. So where do you get the CPU then? It's only these three companies that offer CPU releases. And the reason why you don't know them is because you have to pay for it. This stuff is not freely available on the website. This is one reason why people pay for Java, right? Because this, for us, it's a big effort to do that, to create all these packages and fix only the issues. And of course, someone has to pay for that. So this is the reason why only these three companies have the CPU updates. But you might saw them, if you go to the Oracle download page and you take a look at the JDK 8 downloads, you will find something like 8U, 251, and 252. These are these two different versions. At that point, it was free. Recommendation, okay, development, whatever you like. In production, and I have to say this is more if you only run mission critical stuff, you really should use the CPU if possible. But this is your decision, right? But you can trust me when I tell you we have lots of customers just because of that. Just because they would like to have only the fixes. They say we don't want to introduce any new stuff, it just have to be secure. That's the main reason. Okay. Then the next thing is compliance. And who knows the TCK or heard about it? Probably a lot of people, which is the Technology Compatibility Kit, and it's licensed by Oracle. And what is it? It was originally developed by Sun Microsystems, and it's now the intellectual property licensed by Oracle. And it contains, for example, more than 120,000 tests for JDK 11, and it really tests Java. That means the implementation itself. And to run that test, you need to have installed a sound card. You have to have a printer, a CD-ROM. Everything that is supported by Java, you have to test to pass the TCK, to get the TCK approval. And we have to test any binary that we create. So that means if you go to a download page, for example, on a Mac, you download the package version of the JDK. Because on Mac we have package and we have DMG. We have to run the test for both of them. We can't just run it on the source code and then create the packages. Now we have to run the test on all of these things. And it's more than 1,000 packages for each release that we have to build, right? And that means this is another reason why Java is free for download. Yes, of course, but someone builds that stuff. We have a server farm just to build all these things every 6 months, and someone has to pay for it, right? So it's not for free. Okay, and only if you pass for the packages, then you can label it Java SE compatible, right? And why is that important? It's important because that makes sure that if you run your JDK, let's say JDK A, distribution A, which is TCK licensed, and you change to JDK B, which also is TCK licensed, it's guaranteed that it will work. There won't be any problems by changing the JDK. That's the main reason there is this TCK license. So, and then there's the so-called JCK, right? It's a Java compatibility kit. And this is the actual tests, right? The TCK, it's like an umbrella. And within that, you will find the Java compatibility kit, which is the JCK. I mention that only because on some distributions, they don't say we are TCK compliant, they say we are compliant to the JCK. And the JCK is part of the TCK. I think DRAGONWELL does that. So you have to know these things. And for example, it tests features that are likely to differ across implementations, or they rely on hardware or operating system specific behavior, because running on a Mac is different from running on Linux, is different from running on Windows and other platforms that we know, or that are difficult to port, or either mask abstract hardware behavior or abstract operating system behavior. These are the tests that run, and it's lots of tests, and it takes a long time. And we have to make sure to run these tests, and that when I say we, it's all the companies that build that stuff. There is a release date, and we have to make sure that it's finished at the day so that we can publish all the packages, right? And it takes a long time. How do you get access to the JCK? Because it might be free, or do you have to pay for it? I think nobody knows. You don't have to pay for it. And you must meet the terms of the OCTLA, which is the OpenJDK TCK License Agreement. What a nice acronym. And you also have to sign the OCA, the Oracle Contributor Agreement. It's a lot of paperwork, but you can do. That means you can download the source code of OpenJDK, you can do all the paperwork, and then you can create your own OpenJDK build, which is TCK license, if you pass all the tests. And then you have it for one machine and one package, right? So and then imagine you have to do that for all these different operating systems, CPU architectures, and so on and so on. Okay. And you think, oh, all of them are TCK licensed. No, not all of them. These are the distributions that are TCK compliant for JDK 8. And I mentioned that specifically because you see DRAGONWELL. I mentioned DRAGONWELL a lot this time. I mentioned DRAGONWELL here because they have the TCK compliance for JDK 8. If we take a look at the JDK 9 and above, then there is no DRAGONWELL anymore, because they implemented something in JDK 9 and above, so they just have 11, so it's in 11 and 17, that doesn't really pass the test. So that means if you now change from Red Hat, for example, to DRAGONWELL, your application might fail, because there is something in the JDK which doesn't pass the test. And that's critical. But you see, most of the well-known distributions are TCK compliant for the actual versions. Oh, by the way, who's running on JDK 17 here in production? Okay, 11? 8? Someone 6 or 7? Or do we have some fearless people, 20? No? Okay, cool. Then there is another one which is called Aquavit, which is the Adoptium Quality Assurance, Vitality, and Speed Test Suite. And this is by Eclipse. And the story behind it is, if you ran Adopt OpenJDK, this one was not TCK licensed. And the reason for that was that it had in the name OpenJDK. And this name is trademarked by Oracle. And Oracle said, no, we won't give you the TCK. Even if you pay for it, you won't get it, and you have to change the name. That's the reason why Adopt OpenJDK is dead, and we now have Tamarin. And the next reason, Eclipse created this test suite because they would like to have something similar to the TCK, which is independent from Oracle, right? Where the TCK is more technically really testing the JVM implementation, the Aquavit tests make more sure that it's performant and ready for use in production. These are different tests, and they have more than 350,000 tests that they run in this Aquavit tests. And yeah, like I said, it's designed to test real-world utilization patterns. It's a different approach, right? And yes, of course, security, durability tests we have also. And what they say is you can't get the Aquavit compliance without having the TCK, because it's different tests, right? So to get Aquavit compliant, you also need to be TCK compliant. So what does it mean? You see only these 6 distributions in JDK 11 and above are compliant to Aquavit. All others are not. That doesn't mean anything. The TCK one is the important one, right? Because that makes sure Java itself works. But yeah, these are only the 6 distributions that are really compliant to the Aquavit test suite. And you see, there is no DRAGONWELL here, because in 11, they are not TCK compliant. In 8, they are, but not in 11. And these tests are only available from JDK 11 onwards. Recommended development, you can use whatever you like, but in production, please use a TCK compliant JDK. Very important. Because like I said, if you use DRAGONWELL and you are one in these rare cases where the tests fail, then your production system will fail. And there's no guarantee that DRAGONWELL, why should they fix it? Because they say, we are not TCK compliant, so it's your fault, right? Then we have costs. That might be an important thing. There are free versions, and these are all the free versions you can download and use for free in production. You see this little asterisk on GraalVM, because GraalVM is always a little bit specific, and the same goes for Oracle Open or Oracle JDK is not on this list, because this is only for some time for free. It's a typical Oracle thing. So that means if you, for example, now download GraalVM 17, then you can use it till next year September for free, and if you use it in October, then suddenly the license will change to the formerly OTN license. And that means then suddenly you have to pay not for the vCourse, but for the employees in your company. Yeah, everyone. Also the people that don't use Java. So if you work in a company with 100,000 employees, 5 of them use Java, you pay for 100,000. That's the new pricing strategy with Oracle. So you have to be careful if you use that stuff in production. It's only valid for 3 years, and after that it will fall back to the OTN license where you have to pay for it. Right? So this is a little bit tricky. But you see, all the rest you can use for free, no problem, even in production. Paid versions are available. This is our own one, which is AZUL Platform Prime, where we have base number, of course. Then IBM Samaru certified. You saw this, and the free versions, there was also IBM Samaru. This is the OpenJ9 one. They have 2 different versions. This one has the TCK license. The other one doesn't have. The reason for that is that Samaru is not based on OpenJDK, because IBM did their own implementation of the Java SE spec. They wrote their own compiler, which is an OpenJ9. It's their own stuff. And Oracle said, well, yeah, but then if you would like to have the TCK, you have to pay for it. That's the reason why you have to pay for IBM Samaru certified, because they have to pay for the TCK license, right? Then there's GraalVM. I already mentioned that. It's based on the number of employees. When it falls back to this OTN license, you have to keep that in mind. And the same goes for Oracle JDK, right? So if you download the free Oracle JDK version, be careful. Especially if you use it today on 17, it will fall back to OTN next year in October, and then you suddenly have to pay for it. Okay, performance. Who's interested in performance in the JVM? Yay. You will be surprised. We have baseline support performance, right? So that means this is generally all the same. And this goes for all these distributions. Yeah, there might be differences, tiny ones. Not really something you can measure, which makes a lot of sense. But you see, most of them have the same performance. And the reason for that is obvious. They build on the same source code. Why should one be faster than the other, right? The one difference is Samaru from IBM. It's a little bit faster than OpenJDK. It has a faster startup, and the memory footprint is a little bit smaller because they build their own JVM. All the rest is more or less the same. GraalVM community is probably slower if you do native image stuff, the community version. But the rest, it's more or less the same. So that means there are some exceptions, but if you use one of those, don't expect it to be much faster than the other one. If you need high performance, then you just have a few options. And to explain that, we have to take a look in the JVM how it works, because it contains 3 different systems, like the class loader subsystem, the JVM memory, the execution engine. And the class loader subsystem, again, has different parts like loading part, linking, and initialization, and then we have the JVM memory, where we have the method area, heap, the stack, the PC register, and then the native method stack. Okay, and then the interesting part is the execution engine. That contains the interpreter, the C1 and C2 compiler, the profiler, the garbage collectors, and also it contains native method interface, JNI, and then there is a native method library. So this is the JVM structure, how it looks like. The interesting part is this one, specifically these two parts. Because the JIT compiler and the garbage collector, you can exchange with other stuff, right? And it can still be TCK compliant. If it passes all the tests there, that's fine. So you have to know this one, because if we talk about high performance, then we have, for example, our own JVM, which is called Platform Prime, where we exchange the compiler with our own compiler, which is faster. And we also exchange the garbage collector with our own one. And then we have Oracle GraalVM. They also use a different compiler. They rewrote the C2 compiler in Java and use it in GraalVM. And that's also faster, the code that will be produced afterwards. Feature-wise, so you see, performance is not really that spectacular. You just have a few options. If you really need high performance, then there are just these two features, these two distributions that you can use. Feature-wise, there are more differences, and we will look at that. For example, we saw we have some people here using Amazon CORRETTO, and this comes now with Snapstart. Is someone using that? Not yet. So Snapstart is, it's based on the idea of crack. This is something that we at AZUL created 2 years ago, and we talked about that last year. And the Amazon guys saw that and was like, wow, this is cool, we need that for the Lambdas, right? Because Lambdas really suffer from the startup time. And what it does, you can think about it, you run the application in the JVM, you stop it, you save the complete state, and then you start from there. And the restarting the JVM at this state can take just 30 to 50 milliseconds. This is the same thing that happens when you close in the evening the lid of your laptop and then you reopen in the next morning and everything's there again, right? So the applications are open. We do the same on the JVM. And Amazon, they built their own implementation using the Crack API, and they use Firecracker to make that work, which is a micro JVM. Then we have Alibaba DRAGONWELL, which is big in Asia, and it's made for Alibaba Cloud. So it's a little bit like CORRETTO for AWS is Alibaba for Alibaba Cloud. And they have two different versions. They have the standard version and the extended version. And then they have something called JVM. And the idea is to use the compiler. And when the compiler compiles all the stuff and it optimizes the code, they just try to save that. And the next time you start it, they just tell the compiler, okay, use these optimizations directly. That's the idea behind it. But this is what breaks the TCK tests in DRAGONWELL, this feature. And it is a copy of the stuff that we invented. And we started on the C2 compiler, and then we use it on our own compiler. And they stopped at the point where we left the project open source. So and this is the reason why it's experimental, and it's not really TCK compliant, which is one of the reasons why we created our own compiler, to be TCK compliant. Then they have something called Elastic Heap. That's a GC feature that returns memory of the Java heap to the operating system. This is only in DRAGONWELL. And they have a stack-full symmetric coroutine at JVM level called WISP2. If you take a look at the website, they also have examples on what it is. Then there's Tencent Kona. Is someone working here in the embedded area with Java? Not? Okay. They are specialized on ARM. This is their main focus. And what they did, they implemented so-called Kona fibers, which is Loom, right? In JDK 8 and 11. And they did that already 2 years ago. So the stuff that we get now with 21, they have that in 8 and 11, and it's faster than Loom. And they did that because they are focusing on embedded, and this stuff makes sense on embedded devices. So if you would like to play around with something like Loom on JDK 8, you might want to take a look at Tencent Kona, right? And they also prove it's faster than Loom. They have some benchmarks on their website where you can look it up. The other thing that they do, they ported the ZGC for ARM. So if you run on ARM devices, they did the port of the ZGC. So it's a cool company. They do some cool stuff. they are not compliant to the TCK, but maybe they just didn't apply for it. I have no idea. Then we have Bells of Liberica. Someone using Liberica here? Because it's also quite popular. They have the special thing here is they bundle JavaFX with the JDK, right? Because with JDK 8, up to JDK 8, we had JavaFX as part of the JDK. It came bundled with it. It was never officially a part of the JDK, but they bundled it with the JDK. And Belsoft does the same, also with 17, 11. So every version, you also get always a version that comes bundled with JavaFX, so you don't have to install OpenJFX on the side. Then we have Bells of Liberica NIC, which is the GraalVM thing, a native image kit. The interesting thing here is that you can build a native desktop application using JavaFX, using Bells of Liberica NIC. This is the only GraalVM version that can do it. Even with the Oracle one, you can't, because they bundle all this stuff in GraalVM. So that means a native desktop app, really just one executable, you can do with Liberica NIC, that's a quite nice idea. Then we have Oracle GraalVM, and we have two different versions, and they changed, like I said, so it changed 2 weeks ago. Before it was the community version called GraalVM CE, that you can use in production, and it was much slower than the enterprise version. And then 2 weeks ago, they put out a new license, which is called the Early Adopters license. And if you read through it, then it mainly says, we can do whatever we like, and we owe you nothing. So if you use it, it's your fault. This is more or less what it says. But you can use it for 3 years, and then it will fall back to the OTN license, where you have to pay per employee, right? Keep that in mind. It has a polyglot VM, support for many languages, and it has a GraalJIT compiler. That's what I said already. It's a replacement of the C2 JIT compiler, which is faster. This only goes for the Enterprise Edition, which is now just GraalVM. And it also has the AOT compilation, where you can create native images by ahead-of-time compilation, right? And there was one person using it in production, right? So native image, back there somewhere. You have to keep in mind, if you use the free version and you use the native image, then yes, it's faster startup, but the performance drops a lot, up to 50%. Just keep that in mind. Because if you deploy something to the cloud and you would like to benefit from fast startup, then suddenly you have to pay more because you need more CPU power to get the same performance out of it, right? There is a test on Beldung.com where you can see a comparison between Spring Boot and Quarkus, the JVM version versus the native image version, and then just look at the throughput, and you will see that GraalVM native image is slower, right? So it's really, but that only goes for the community version. If you use the enterprise version, then this is as fast as Java. Then we have IBM Samaru. Again, we have these two different versions. I already explained why there is a certified version, because they have to pay for it. It's based on OpenJ9, which is the IBM JVM. It has a faster startup, lower memory consumption, and they also have an AOT compiler, and they can dynamically compile AOT code, which is a little bit strange because usually AOT means ahead-of-time compilation. How can you do that dynamically? I have no idea. But they claim they can do it, and they can prove it. So they have benchmarks where they can show that it has really an impact on startup time. They have Instant On, which is exactly the same what Crack is. They just name it Instant On, and they do exactly the same. They have a different API, and the reason why there's a different name and everything is because the JVM is not based on OpenJDK, right? So they always, if there are features in OpenJDK, they have to implement it again and have to, usually they give it a different name. And then they have something called a JIT server. That means you can run one version of Samaru, let's say, on a server, and then you have multiple other nodes, and when you run the same microservice, then the first one compiles it, calls the JIT server, then the compilation will take part in the cloud, in that central JIT server, and it will return the compiled method. The next time then the same service calls the method, it will directly get back the compiled version. Right? You save the whole compilation process. Right? This is the idea behind it. Then we have AZUL, which is all built of OpenJDK, And we also have a version that comes bundled with JavaFX, the same as Liberica. We have an inbuilt vulnerability detection. And I have to ask you, who's using a security scanner here, for example, in the IDE? Should be more. You never check for security issues when you code, okay? Who's using that in CI/CD systems? Okay, and who's using that in production? Okay, a few. The reason why this is just a few people mainly is because if you would like to run security scans in production, then usually you have to use an agent. The agent is a program that runs besides the JVM, and it talks to the JVM. It has some callbacks in the JVM. For example, every time a class is loaded, the JVM tells the agent, I loaded a class, and then you can do a check if this is vulnerable or not. And we saw that problem, and we thought the JVM loads the classes anyway, so the JVM can directly call to a so-called, we name it forwarder, and the forwarder will then check against a web service. And the advantage is that the JVM, because it collects all the data anyway, just from time to time calls this forwarder and sends him all the messages, what was loaded, and then the work is done by the forwarder, right? So the JVM can continue running without the performance overhead, because if you have an agent, then usually it's at least 10% overhead, because the agent also needs some CPU time to run. So this one is, the big advantage here is that you can run your code. It will tell you at runtime what classes have been loaded, what libraries do you use, are they vulnerable, and the best thing is, do you use them? Because if you run it in CI/CD, then they can just check if you, for example, have a dependency on log4j. They can tell you, oh, this is vulnerable, you have to change it. They can't tell you if you ever load the classes. Well, we can. We can tell you, okay, you have a dependency that's vulnerable, but you never load the code. So you're on the safe side, but still you should better change it, right? So this is the AVD, or AZUL vulnerability detection thing. Then crack, I already mentioned that, where you do the snapshot in the JVM, and you can restore from there in milliseconds. And we have a officially supported version out there that you can download for free and use for free. And then we have the last one, which is the AZUL Platform Prime. And there's so many features. So we have a different JIT compiler that it's based on LLVM, which is much faster than the C2 compiler in the JVM. Then we have our own garbage collector, which is the C4, which is in principle the same as the ZGC, but we did that already 10 years ago, and we have a patent on that one. And the ZGC that's coming is more or less the same garbage collector than the C4. Then we have Ready Now. This is the stuff which is JVM up in DRAGONWELL, but we came to the point that we broke the TCK, then we invented our own compiler. And this saves all the optimizations and de-optimizations that are running in your code. The next time you start it, it just directly tells the compiler, compile it like this. This is the optimum thing to compile it, right? So you don't have to go through all these de-ops things. And then we have, this is similar to the Samaru JIT server. We also have a cluster that you can install in your Kubernetes cluster, and we have the compiler in the cluster. And then every time you call, let's say if you compile code in the JVM, it first goes through interpretation. If a method was called 1,000 times, it will go into the C1 compiler, compile the code. And if the same method then was called another 5,000 times, then it will go into the C2 compiler. And this one does all these optimizations to the code. The C1 doesn't do. And at that point, where it comes from C1 to C2, we just call the web compiler, right? This is the cloud native compiler. And then this one keeps all the compiled methods and then just returns the compiled code, which is much faster. And it also has the vulnerability detection that I explained, and it also will become crack in the near future. So the takeaway from that session, and it was a little bit dry, I'm sorry for that, but this is, we always face the people coming to the booth and they ask us some stuff and you figure out they have no idea about what is Java, what is available. So are all those builds of OpenJDK really different? Technically, no. It's more or less the same. Service support and cost, yeah, there are big differences there. You saw that. Also feature-wise, right? So there's probably a difference there. So if you choose a JDK, choose it wisely. And if you use, for example, CORRETTO on your desktop machine, then ask yourself why you do that. This was made for AWS. You can do, but there's not really a reason to do so. And with this, I say thank you. And we still have 5 minutes left if there are questions. And if not, you can also come to the booth. I will be also there tomorrow for a workshop. So if there are any questions, feel free to ask them now. And if not, feel free to go. Thanks.